Very good morning, students. Today onwards, we are sending YouTube links for second PU students in the chemistry subject. Today onwards, we are sending YouTube links for second PU students in the chemistry subject. Remember, student, in each week, 4 days, Monday, Tuesday, Wednesday, Thursday, 4 days, we are sending 8 video links totally. That is Monday 2 video links, Tuesday 2 video links, Wednesday 2 video links, and Thursday 2 video links. Totally in a week you will get 8 video links in our chemistry subject. At the same time, these 2 video links are coming from same chapter only, that is haloalkanes and haloarenes. Haloalkanes and haloarenes. For example, in Monday, haloalkanes and arenes, video 1, video 2. In Tuesday, video 3, video 4. In Wednesday, video 5, video 6. In Thursday, video 7, video 8. Totally 8 videos in a week you will get, students. And Friday, Saturday, Sunday, you didn't get any YouTube links. And these 8 video links in a week you have to complete thoroughly and perfectly. At the same time, MyPal classes going on simultaneously, solution chapter. MyPal classes going on solution chapter. That also you can prepare perfectly. Therefore, you will get a clear idea. In YouTube classes, perfectly one chapter going on, that is theory as well as competitive, that is haloalkanes and haloarenes. In MyPal classes, one chapter is completely going on, theory and competitive, that is solution chapter, that is, student. If you follow this procedure, then our syllabus will be completed within that time. Then you will get more time for the revision also. Right, students? Then we are entering into our chapter, student, that is haloalkanes and haloarenes. Haloalkanes and haloarenes. The marks weightage in the PU board, student, 6 marks. Total PU board out of 70 marks, the marks weightage will be 6 marks, students. One 1 mark question and one 5 mark question you will get. Total weightage will be 6 marks. Now first, student, introduction of haloalkanes and haloarenes. Some basic points are required, students. That basic points I will tell first. After that we are entering into the chapter. Right, students, first one, in your first PUC in general organic chemistry you are discussing these basic points, but I will recall this information once again. Aliphatic hydrocarbons. Observe the cursor, student, clearly where I am arranging the cursor. With a red mark, student, then it will be very easy to recognize. Right, students? Aliphatic hydrocarbons. Generally, student, acyclic hydrocarbons are known as aliphatic hydrocarbon. Acyclic means the hydrocarbons which are not cyclic in nature. The hydrocarbons which are not cyclic in nature are called acyclic hydrocarbons. These acyclic carbons are also known as aliphatic hydrocarbons. Examples are alkenes and alkynes. Right, student. Next one, halogens. Group 17 elements are known as halogens. Those are fluorine, chlorine, bromine, iodine. Astatine is also present but is radioactive, student. We cannot consider. The familiar halogens are fluorine, chlorine, bromine and iodine. Therefore, halo means immediately we will recognize these 4 halogens, that is fluoro, chloro, bromo and iodo. Right, student. Next one, observe cursor, student. Aromatic hydrocarbons. The cyclic hydrocarbons which obeys aromaticity rules, which obeys aromatic rules, which obeys aromatic rules are known as aromatic hydrocarbons, are known as aromatic hydrocarbons. The cyclic hydrocarbons, observe student, aliphatic or acyclic hydrocarbons, aromatic or cyclic. The cyclic hydrocarbons, which obeys aromatic rules, which obeys aromatic rules are known as aromatic hydrocarbons, are known as aromatic hydrocarbon, which are also known as arenes, which are also known as arenes. For example, student, here aromatic rules means in your first PUC in aromatic compounds, aromatic hydrocarbons, there are three rules are there. One is 4n plus 2 pi electron rule, one is a cyclic structure and conjugation. Once again recall that information in your first year book, students. Okay, here our important point is the cyclic hydrocarbons, which obeys aromaticity rules are known as aromatic hydrocarbons, aromatic hydrocarbons. I will repeat once again, student. Aromatic rules means 4n plus 2 pi electron rule is followed, that is aromatic compound, and a cyclic structure is there, that is also aromatic compound. With a cyclic structure and 4n plus 2 pi electron rule is following are known as aromatic hydrocarbon, aromatic hydrocarbons. Clear, students? Right. All these points discussed in your first PUC syllabus, students. That is halogens, group 17 elements, aliphatic hydrocarbons and aromatic hydrocarbons. Next, students, for aromatic hydrocarbons, the examples are one is benzene, student. One is benzene. Next one is toluene. Benzene and toluene are the examples for aromatic hydrocarbons. Aromatic hydrocarbons. Benzene structure is like this, student. Toluene structure is like this. Toluene structure will be like this. It is also discussed in your first PUC, students. Aliphatic hydrocarbons or acyclic hydrocarbons, aromatic hydrocarbons, aromatic hydrocarbons. Clear, students? It is in your first PUC syllabus already we are completed. That is introduction, student. Now we are discussing about our chapter haloalkanes and haloarenes. First definition, student. Line to line we are discussing. The compounds which are obtained, by the replacement of one or more hydrogen atoms of aliphatic hydrocarbons with one or more halogen atoms are known as halogen compounds, The compounds which are obtained by the replacement of one or more hydrogen atom, or more hydrogen atoms of aliphatic hydrocarbons like alkanes and alkynes. Just now we are discussing acyclic hydrocarbons like alkanes and alkynes, aliphatic hydrocarbons. That is one or more hydrogen atoms of aliphatic hydrocarbons with one or more halogen atoms, are known as halogen compounds. That is, if one halogen atom is substituted, to more halogen atoms are substituted. Those compounds are called halogen compounds. Right, students. These compounds are termed as halogen derivatives of aliphatic hydrocarbon. These compounds are termed as halogen derivatives of aliphatic hydrocarbon because in the aliphatic hydrocarbons the hydrogens are replaced with halogen atom. Hence these are also known as halogen derivatives of aliphatic hydrocarbon. The definition can be like this, student. The halogen derivatives of alkenes and alkynes are known as haloalkenes and haloalkynes. If the hydrogen atoms of alkanes are substituted with the halogen, haloalkanes. If the hydrogen atoms of alkenes substituted with the halogen, haloalkenes. If the hydrogen atoms of alkynes substituted with the halogen, haloalkynes. Haloalkynes. The halogen derivatives of alkenes and alkynes are known as haloalkanes and haloalkenes and haloalkynes. Clear students? Right. This is about the definition of the halogen compounds or halogen derivatives of aliphatic hydrocarbon. Clear students? Right. In our haloalkanes and haloarenes chapter, in detail we are discussing only one topic, student, that is haloalkanes. Haloalkanes. Okay, next continuation, students. In the previous session we are completed haloalkenes and haloalkanes. In our syllabus we are discussing in detail about haloalkanes. Haloalkanes means, student, in alkanes some of the hydrogen atom replaced with halogen atoms are known as haloalkanes. That is, the compounds which are obtained by replacing one or more hydrogen atoms of alkenes with the halogen atoms are known as haloalkanes. Once again I repeat, student, the compounds which are obtained by replacing one or more hydrogen atoms of alkenes with the halogen atoms are known as haloalkanes. For example, methane, simple alkane will be methane, CH4. One of the hydrogen atom is subtract and one halogen atom is added. Then the compound is CH3X, that is halomethane. Methane is converted to halomethane. By replacing one hydrogen atom with one halogen atom. Minus H means one hydrogen losses, plus X means one halogen atom will be added. Remember the, student. Similarly, ethane, C2H6 minus H plus X gives C2H5X, which is known as haloethane. Ethane is converted to haloethane. Clear, students? Right. Now we are discussing about haloarenes. Observe, student, you can observe the cursor clearly. That is, the compounds which are obtained by the replacement of one or more hydrogen atoms of aromatic hydrocarbons or arenes with one or more halogen atoms are called halogen derivatives of aromatic hydrocarbon, which are also known as haloarenes. In the aromatic hydrocarbons, one hydrogen atoms or more hydrogen atom replaced with one or more halogen atoms are known as halogen derivatives of aromatic hydrocarbon, or haloarenes are known as haloarenes. The compounds which are obtained by the replacement of one or more hydrogen atoms of aromatic hydrocarbon with one or more halogen atoms are called halogen derivatives of aromatic hydrocarbons, or haloarenes. For example, student, here C6H6, that is benzene, student. C6H6, that is benzene, minus H plus halogen. One hydrogen atom replaced with one halogen atom to form C6H5X, which is known as a halobenzene. Benzene losses one hydrogen atom and one halogen atom is added to form halobenzene. Benzene is converted to halobenzene by the replacement of one hydrogen atom with one halogen atom. The structure of benzene is like this, student, very familiar in your first PUC. In this, one hydrogen atom replaced with one halogen atom. One hydrogen atom replaced with the one halogen atom. Halobenzene. Halobenzene. It is a structure. It is the formula C6H5X. C6H5X. Clear, student? These are the two definitions of the haloalkanes and haloarenes. Our chapter, student. Haloalkanes and haloarenes. How can you define haloalkane, students? Right, here I am discussing. The compounds which are obtained by the replacement of one or more hydrogen atoms of alkanes with the halogen atoms are known as haloalkanes. Haloarenes means, just now we are discussing, student. Haloarenes means the compounds which are obtained by the replacement of one or more hydrogen atoms of aromatic compounds. One or more hydrogen atoms of aromatic compounds or arenes are known as haloarenes. Example is halobenzene. If you take as fluorine as halobenzene, fluorobenzene. If X is equal to fluorine, fluorobenzene, chlorine, chlorobenzene, bromine, bromobenzene, iodine, iodobenzene. Definition you will get more clarity, students. I will repeat once again. The compounds which are obtained by the replacement of one or more hydrogen atoms of alkanes with the one or more halogen atoms are known as haloalkanes. Haloarenes means the compounds which are obtained by the replacement of one or more hydrogen atoms with one or more halogen atoms are called haloarenes. Haloalkanes example, student, chloromethane and chloroethane. And haloarenes example is halobenzene, like fluorobenzene, chlorobenzene, bromobenzene and iodobenzene. Right, students. Next one, student, classification of haloalkanes and haloarenes. Classification of haloalkanes and haloarenes, student. Classification of haloalkanes and haloarenes. Observe red mark, student. Haloalkanes and haloarenes. Based on number of halogen atom, classification of the haloalkanes and haloarenes, student. First one, monohaloalkanes and haloarenes. That is monohaloalkanes and monohaloarenes. That word gives the student. Remember, mono means single. Mono means what, student? Single. Mono means single. These compounds containing only one halogen atom. The compounds which contains only one halogen atom are known as monohaloalkanes and monohaloarenes. For example, student, ethane. What is the formula, student? C2H6. It can be written as CH3 single bond CH3, CH3 single bond CH3 minus H plus chlorine. One hydrogen atom replaced with one chlorine atom. Which is known as bromoethane. Here also you will take bromine. Because here bromine is present. That is, when ethane, one hydrogen atom is replaced with the bromine atom to form bromoethane. That is, ethane can be converted to bromoethane. It is nothing but haloalkane. Here halogen is bromine, bromo, and alkane contains two carbon atom, ethane. Therefore, bromoethane, monohaloalkane, student. And arenes are also there. In benzene, only one hydrogen atom replaced with one chlorine atom to form chlorobenzene. Here we know that benzene contains 6 hydrogen atom. Among the 6 hydrogen atom, one hydrogen atom losses and one chlorine atom is added to form chlorobenzene. Benzene can be converted to chlorobenzene. Clear, students? Right. Next one. That is about monohaloalkane, student. Monohaloalkanes. Second one, student, we are discussing, that is dihaloalkanes. and arenes, dihaloalkanes and dihaloarenes. Observe student, these halogen compounds contains two halogen atom. That word gives the meaning student. Di means two. The haloalkanes and haloarenes contains only two halogen atoms are known as dihaloalkanes and dihaloarenes student. For example, ethane, we know that C2H6, CH3 single bond CH3, minus 2 hydrogen atom plus 2 bromine atom. If two hydrogen atoms are replaced with two bromine atom, it can form CH3, CH, Br and Br. Among these three hydrogen atoms, two hydrogen atoms are replaced with two bromine atom. Hence, it is known as dihaloalkane. Here observe student, these two halogen atoms are present on the same carbon atom. Hence, it is known as geminal dibromide or gem dibromide. Very important student. The dihalogen compounds in which the two halogen atoms present on the same carbon atom are known as geminal dihalide, or bromine is present geminal dibromide, which can be simply known as gem dihalide. Gem means the two halogen atom present on the same carbon atom. In PU board examination, this question is given only 1 year, that is, give one example for geminal dihalide. Sometimes they will ask especially halogen also. Give one example for geminal dibromide. Geminal means it is student. Geminal means it is the compound. Once again student, the halogen compounds contains two halogen atoms are known as dihaloalkanes and dihaloarenes. For example, ethane, the two hydrogen atom replaced with two bromine atom to form geminal dibromide, which is also known as gem dibromide. Next one student, here another case. Let us consider ethane. Here also the two hydrogen atoms are replaced with two bromine atom, but one bromine atom replaces first hydrogen atom present on first carbon atom. One bromine atom replaces hydrogen atom present on the second carbon atom. It is also dihaloalkane student. Why? Because the two hydrogen atoms are replaced with two halogen atoms. Our condition is obeyed. Therefore, it is dihaloalkane. But this is known as vicinal dibromide. If the two halogen atoms are present on the adjacent carbon atom, that is first carbon, second carbon, or third carbon, fourth carbon, like this adjacent carbon atom, side by side carbon atom are known as vicinal dibromide. The halogen compounds in which the two halogen atoms replaced with two hydrogen atoms, are replaced with two halogen atoms are known as vicinal dibromide. Once again student, the dihalogen compounds in which the two hydrogen atoms are the dihalogen compounds in which the two hydrogen atoms replaces two halogen atoms, but the replaced hydrogen atoms are adjacent positions only. These type of halides are known as vicinal dihalides. Since here bromine is present, that is known as vicinal dibromide. Conclusion student, both compounds are comes under dihaloalkanes, but first one is geminal dihalides because the two bromine atom present on same carbon atom. Second one is vicinal dibromide because the two bromine atom present on the adjacent carbon atom. Right student. Next one, arenes we are discussing. In benzene, the two hydrogen atoms are replaced with two halogen atoms are known as dihaloarenes student. The both compounds can be considered as dihaloarenes. Observe student, Here the benzene formula will be C6H6. C6H6. Among the 6 hydrogen atom, the 2 hydrogen atoms are replaced with chlorine atom. Hence the molecular formula for these three compounds is C6H4Cl2. C6H4Cl2. That is 1,2-dihalo compound, 1,3-dichloro compound, 1,4-dichloro compound. Here students, in the place of halogen, chlorine is present. Hence these three compounds can be considered as dihalo compound. Dihalo compound. The two hydrogen atoms may be replaced here, may be replaced here, may be replaced here also. Here some special name is also there student. It is ortho-dichlorobenzene, meta-dichlorobenzene and para-dichlorobenzene. Para-dichlorobenzene. All are dichlorobenzenes, but first one is ortho-dichlorobenzene. Second one is meta-dichlorobenzene. Third one is para-dichlorobenzene. Para-dichlorobenzene. Clear students? Para-dichlorobenzene. And IUPAC name and some introduction is also there student about this compound. In detail we are discussing in the IUPAC nomenclature. Until you remember, benzene can form three types of dihalogen compounds. Those are ortho-dihalogen compounds, meta-dihalogen compounds and para-dihalogen compounds. Okay students, right. Next one student, third one, trihaloalkanes and arenes. Trihaloalkanes and arenes. Trihaloalkanes and arenes. Trihaloalkanes and trihaloarenes student. These compounds contains 3 halogen atoms. These compounds contains 3 halogen atoms. For example, propane student, CH3, CH2, CH3. If 3 hydrogen atoms replaced with 3 halogen atoms, 3 hydrogen atom replaced with 3 halogen atom, that is CH2Br, CHBr, CH2Br. It is known as tribromopropane. That is bromine it changes to tribromopropane. Bromine it changes to tribromopropane. Tribromopropane. These compounds contains 3 halogen atoms. These compounds contains 3 halogen atoms. Right students. Propane changes to the tribromopropane. Next one students, in haloarenes. In benzene, the molecular formula is, we know that C6H6. Among the 6 hydrogen atom, the 3 hydrogen atom replaced with 3 bromine atom. 3 bromine atom. It can form like this students. Here one hydrogen atom replaced, here one hydrogen atom, here one hydrogen atom. Among the 6 hydrogen atom, the 3 hydrogen atom replaced with 3 bromine atom. 3 bromine atom. Hence it is trihaloarene. Trihaloarene. Since bromine atoms are present, tribromoarene. Tribromoarenes are tribromobenzene student, because it is the benzene compound. Tribromobenzene. For example, in the same compound, the 3 hydrogen atoms are replaced with 3 bromine atom. 3 hydrogen atoms are replaced with the 3 bromine atom. But here student, you can observe the positions will be different student. The positions will be different. Here one position, here one position, here one position. Different positions are present. Anyway, it is also tribromobenzene. Clear students? Right. Next student, observe the cursor. Polyhaloalkanes. That word gives the meaning student. Next continuation students, we are discussing about polyhaloalkanes. Polyhaloalkanes, fourth category. Right students, first definition we are discussing. These halogen compounds contains more than 3 halogen atoms. Like tetrahaloalkanes, pentahaloalkanes, hexahaloalkanes. Similarly, tetrahaloarenes, pentahaloarenes and hexahaloarenes. depends upon number of halogen atom, maybe tetra or penta or hexa, haloalkanes or haloarenes students. Some examples we are discussing students. CH4, that is methane. In methane, the 4 hydrogen atoms are replaced with 2 fluorine atoms and 2 chlorine atoms. Here 2 fluorine atoms are 2 chlorine atoms replaced with 2 fluorine atoms. Then CF2Cl2 is obtained, which is known as chlorofluorocarbons. Chlorofluorocarbons, which are known as CFCs, CFCs. In the environmental chemistry we are discussing student, that is the hydrocarbons which are responsible for the depletion of ozone layer is known as CFCs, which are known as chlorofluorocarbons. Those are also obtained from the alkanes only, that is methane. In methane, the 4 hydrogen atom replaced with 2 chlorines and 2 fluorines. CF2Cl2 is obtained, which is known as dichloro-difluoromethane. In detail we are discussing in the IUPAC nomenclature student, until you remember, which is known as chlorofluorocarbons, which are known as CFCs. It is tetrahaloalkane student, tetrahalomethane. In benzene student, C6H6. The 6 hydrogen atoms are replaced with benzene C6H6. Among the 6 hydrogen atom, 4 hydrogen atoms are replaced with 4 chlorine atom, which is known as tetrahalobenzene. In benzene, among the 4 hydrogen atoms, among the 6 hydrogen atoms, 4 hydrogen atoms are replaced with 4 chlorine atom to form tetrachlorobenzene. Next one student, DDT. DDT stands for diphenyl trichloroethane. What is students? Diphenyl trichloroethane. The full form student, very important. Here 5 halogen atoms are present. Hence it is known as pentahalogen compound. The structure is like this student. Here 5 chlorine atoms are present and 2 benzene rings are present. It is known as pentahalogen compound. Diphenyl trichloroethane. Clear students? Next one. In examination they will ask student, DDT, how many chlorine atoms are present in DDT? What is the full form of DDT? Okay student, in detail we are discussing in the PolyHalo alkenes. Clear students? It is about first topic student, that is introduction of the haloalkanes and haloarenes. Clear students? Briefly I will recall this information once again. It will be helpful to you. Right students, briefly recalling haloalkanes and haloarenes introduction student. Right, first one is aliphatic hydrocarbons students. Acyclic hydrocarbons are called aliphatic hydrocarbons. Examples are alkanes, alkenes and alkynes. Halogens means group 17 elements are known as halogens: fluorine, chlorine, bromine and iodine. Aromatic hydrocarbon means the cyclic hydrocarbons which obeys aromatic rules are known as aromatic hydrocarbon, which are known as arenes. Examples are benzene and toluene. Next students, the compounds which are obtained by the replacement of one or more hydrogen atoms of aliphatic hydrocarbons with one or more halogen atoms are known as halogen compounds. The halogen derivatives of alkanes, alkenes and alkynes are known as haloalkanes, haloalkenes and haloalkynes. For example, from methane, halomethane is obtained. From ethane, haloethane is obtained. Next student, the compounds which are obtained by the replacement of one or more hydrogen atoms of aromatic hydrocarbons with one or more halogen atoms are known as haloarenes. Example student, benzene and halobenzene. Benzene converted to halobenzene. For the aromatic haloarenes. Next student, classification of the haloalkanes and arenes student based on number of halogen atoms student. If one halogen atom is present, monohaloalkanes and monohaloarenes. Examples we know that bromoethane and chlorobenzene. If two halogen atoms are present, dihaloalkanes and dihaloarenes. These dihaloalkanes are of two types students, geminal dihalide and vicinal dihalide. Geminal means two halogen atoms present on same carbon atom. Vicinal means two halogen atoms present on adjacent carbon atom or side by side carbon atom. Dihaloarenes are of three types student, that is ortho-dihalobenzene, meta-dihalobenzene, para-dihalobenzene. Here three categories are there student. First one is ortho, meta and para-dichlorobenzenes. Next student, trihaloalkanes. These compounds contains three halogen atoms. Three halogen atoms are known as trihaloalkanes or haloarenes. For example, propane student. Three hydrogen atom replaced with three bromine atom to form tribromopropane. Similarly, in benzene, the three hydrogen atom replaced with three hydrogen atom to form tribromobenzene. Different types of tribromobenzene are formed. Next students, lastly we are discussing PolyHaloalkanes. These halogen compounds contains more than 3 halogen atoms, tetra, penta and hexahaloalkanes. Methane, 4 hydrogen atom replaces 4 chlorine atom to form tetrachloromethane, that is CCl4, that is polyhaloalkane. Similarly, the 4 hydrogen atom replaced with 2 fluorines and 2 chlorines to form dichloro-difluoromethane, which is also known as chlorofluorocarbons. Next, in benzene, the 4 hydrogen atom replaced with 4 chlorine atom to form tetrachlorobenzene, which is also polyhalo. Lastly, student, DDT, the full form dichloro-diphenyl trichloroethane. Here, the 5 chlorine atoms are present student, which is pentahalogen atom, which is pentahalogen compound. In examination, how many chlorine atoms are present in DDT? 5 chlorine atoms are present. Right student. With this, the classification will be completed student. With this, the introduction part, that is classification of the halogen compound based on the number of halogen atoms, is completed students. Second topic we are discussing classification based on hybridization of the carbon atom student. Copy this student.